Welcome to The Explainer. Today, we're diving into something pretty cool. How can AI do more than just follow orders? How can it actually, reason about the world?
So let's kick things off with a big question. Imagine you had to build a robot. How would you design it to explore, say, a dark cave it's never seen before, and make smart, safe choices? Without just blindly bumping into things.
Well, the answer that AI researchers came up with is this really powerful idea called a knowledge-based agent. And it's exactly what it sounds like, an AI that's built to know things and then use that knowledge to figure stuff out.
Okay, so how does one of these agents actually think? Well, it really boils down to two key parts that work together. First, you've got what's called the knowledge base, or KB for short. The best way to think of this is like the agent's brain. It's long-term memory. It's just a collection of sentences, of facts about the world that it's learned so far.
And then second, you have the inference engine. Now, if the knowledge base is the memory, the inference engine is it's the reasoning part. It's the set of rules and algorithms that can look at all those facts and say, okay, based on this and that, I can figure out something totally new.
And these two things work in a constant loop, right? The agent senses the world around it, then it tells its knowledge base, hey, here's what I just saw. And then it asks its knowledge base, okay, now what? What should I do next?
So, to really put an agent like this through its paces, AI pioneers came up with a classic test. It's a kind of virtual obstacle course for logic, and it's called the Wumpus World.
All right, so let's get into this. Picture a simple grid of caves. Our little agent's goal, get in, find the gold, and get out. Sounds easy, right? Well, not so fast. Because somewhere in that cave, there are bottomless pits and a horrible monster called the Wumpus.
But here's the kicker, and this is the really important part. The agent is basically in the dark. It can't see the whole map. It only knows about the single square it's standing in. So, how does it survive? It uses its senses. If it's next to a pit, it feels a breeze. If it's near the Wumpus, it smells a stench. And that's it. Those little clues are all it has to figure out where the dangers are.
Okay, so let's walk through this. Let's see how this agent uses pure, cold logic to make its first few moves and, hopefully, stay alive. All right, step 1. The agent starts out in square 1-1, the safe zone. It takes a sniff, feels for a breeze, nothing. And this is key. The lack of a clue is itself a clue. It tells its knowledge base, hey, no breeze, no stench. And the knowledge base concludes, got it. That means the squares next to us, 1-2 and 2-1, have to be safe.
So, it makes a move. It goes to one of those safe squares, 2-1. But now. And boom, the inference engine kicks in. The agent tells its knowledge base, I feel a breeze here. The engine knows the rule. Breeze means a pit is nearby. Now, we already know 1-1 is safe, so the pit has to be in one of the other adjacent squares, either 2-2 or 3-1. It doesn't know which one yet, so it marks them both as dangerous possibilities.
Now, a good logical agent doesn't take stupid risks. So what does it do? It backs up. It goes back to the safe square 1-1 and tries the other path it knew was safe, moving to 1-2. And in this new square, it smells a stench. Another new fact for the old knowledge base.
Okay, get ready because this is the really cool part. This is the big logical leap. The agent now combines everything it knows. The stench here means the Wumpus is in 1-3 or 2-2, but it remembers that back in square 2-1, there was no stench. Think about it. If the Wumpus was in 2-2, it would have smelled it from both spots. Since it didn't, that's a flat-out contradiction. So the Wumpus cannot be in 2-2. It must be in 1-3. And if the Wumpus isn't in 2-2, that solves the other puzzle. The pit we were worried about must be in 3-1. And just like that, with pure logic, the agent has proven that square 2-2 is completely safe to enter. Amazing, right?
I mean, that's a seriously impressive bit of detective work. But how does the agent, actually handle all these possibilities in its code? Let's pop the hood and take a look.
So the way the inference engine works is by thinking about all the possible ways the world could be. Logicians call these models. So if you've got 3 squares you're not sure about, like we see here, there are actually 8 different possible arrangements, 8 possible worlds for where the pits could be.
And here's how it uses that. Every piece of information the agent gathers, like no breeze in the start square or a breeze over in this other square, acts like a filter. It takes all those 8 possible worlds and just throws out the ones that don't fit the facts. Whatever's left over, those are the only realities that are still logically possible.
The engine that drives all of this is something called propositional logic. It sounds fancy, but the core idea is simple. It's just a super precise language for turning things we observe into simple statements that are either true or false. Then you can connect them with basic words like and, or, and not.
So, every single deduction the agent makes, no matter how complicated it seems, is just built up from these simple true or false rules. A rule like, if I feel a breeze, then there is a pit nearby, gets turned into a formal sentence, and the inference engine can process that sentence with total mathematical certainty.
So, okay, Wumpus World is a cool game. But what's the point? Why does this little exercise in a virtual cave actually matter?
Well, what the Wumpus World shows us so perfectly is a fundamental idea in AI. And it's that you can get really complex, really smart-looking behavior to emerge from a surprisingly simple recipe. Just give an agent a way to store facts and a way to reason about them logically.
And this isn't just for games, not by a long shot. This basic idea, knowledge base plus inference engine, it's a cornerstone for all sorts of advanced AI. We're talking robotics, natural language understanding, even medical diagnostic systems.
Which kind of leaves us with a pretty deep question to chew on, doesn't it? If an AI can perform these amazing feats of reasoning, all built up from simple, provable logic, what does that say about our own minds?